When you start creating databases of your own, it's inevitable that you'll initially come into some difficulty when it comes to deciding what data to store and how to store it in which tables. And this problem is common across almost every database administrator when they're first creating their first tables. You then identify what will eventually be the primary key. A primary key is simply just an index. It's a number which you can refer to, which somehow connects all of the different elements within your database. If you're in school or college or university, you'll no doubt have a student number. If you're in employment, you'll no doubt have a staff number. In our case, the staff number is the connecting field which will connect every single attribute within the database together, because staff is ultimately what we're dealing with in our database. When we've identified our primary key, we simply underline it. We then systematically go through all of the fields and identify the level. The best way to describe the level is to consider whether each individual field is unique to the identified primary key. So for example, on this table, for every primary key or every staff number, we're going to have one staff surname, we're going to have one staff job title, and that one staff number is going to have one manager's number associated with it. So too is that staff number going to have one hire date associated to it, one salary, one commission, one grade, one low salary and one high salary. In our example, it's perfectly possible for one member of staff to work in two different departments. They could work two different jobs for the same company. They could also have multiple training courses. And so the department number, the course ID number, the course title, there can be multiple of all of them for each staff number, and so these are identified as level 2. And so the next step is to copy all of the fields who have level 1 across to the first normal form column. These just get copied across directly. We also copy across a duplicate of the staff number, which is our primary key, and we separate that out into a separate group of fields. We also then copy across all of the fields which we've identified as being level 2, and we find another primary key from those fields. So in this case, department number is also a primary key, because the department number will help group together all of the rest of those fields. We then look at each group to see which groups have multiple primary keys. In our case, only the bottom group has multiple primary keys, and so we then need to check whether each field within that group actually relies on both of those primary keys. In this instance, we can see that the department name and the department location only rely on the department number. If you had the department number, you would be able to identify the department name and the department location. You don't also need the staff number in order to do this, and so we separate that out into another table, into another group, and we identify the department number as being a primary key in this new group. We must then identify the third normalised form. To identify the third normalised form, we need to review each individual field within each individual group and see whether it's possible to separate it out further. So in this example, if we had the grade, we would then be able to identify the low salary and the high salary, and so we can separate the grade out into its own unique table. When we separate groups out in this final third normalised form, we must also leave a reference to that field in the originating group. So you can see here we've got asterisk grade at the end of the first group. This is what's called a foreign key. This is how we link tables together. And we've done the same thing again in what's now the third group. We've identified that to find the course title, all you really need is the course ID. You don't also need the staff number and the department number to find the course title. It's literally a matter of if you have the course ID, you can then find the course title. Finally, we identify names for each of the groups. So in the first group we've called it staff, because everything in that group relates to staff. We then have a grades table, because everything in that group relates to the grades. We then have a staff training table. The next group we've called training. We could easily have called it course, but because we did call the next group training, it's best practice to use the names of both groups combined in this way, so that you know which actual tables this group connects. So this group, the third group, will connect the staff group and the training group together. Finally, we have the department group, because everything in the final group is related to the department. So let's compare what we've done in our normalisation exercise to what we actually have in our database. We have roughly the same fields. We have the customer, the department, the salary range, which we call grade. We've got staff, we've got staff training, and we also have training. We'll ignore this staff table because staff table is the view that we created in one of our other lessons. So the actual table names are roughly the same as what we would expect if we followed the normalisation exercise through on our data now. We can also look at what fields we should expect in our current tables compared to what we have in our database right now. So as you can see, we have the staff number, staff surname, job title, manager number, hire date, salary, commission and department number. The only fields that we don't have in this database, which we do have in the normalisation exercise, is the grade, and we've already determined that we can calculate the grade based on the salary of the individual. If we wanted to, we could of course add the grade into this table. So let's do the same for grade. Which in our table we've called salary range. So we have the grade, low salary and high salary, and they are the same as what we would expect from our normalisation exercise. So let's do the department. So we have department number, department name and department location. Again, these are what we would expect based on our normalisation exercise. We also have a customer table in our database. And we'll actually look at the data in here. You can see straight away that this table hasn't been normalised. There's all sorts of data which is duplicated, which could be separated out into separate tables. If you think back across the principles that we've discussed, you would most likely have a customer number in this table and a customer table separate, which stores information, things like the customer's name, the customer's city, country. And you would probably also have a menu item table, which has information about the menu item name. And we would have a foreign key here for the menu item number. So in this table you would probably have the columns customer number, order date, menu item number and order quantity, and that would basically amount to what a customer ordered on a specific day. We don't need to duplicate all of this detail, and doing so is actually bad for the database because it means that we have to store all of this additional data. Now we're not actually going to do anything with this table to correct this. The entire point of including the customer table within this database was purely to illustrate the fact that unnormalized data is very poorly structured and it will hurt your database in the long run.